everyone. So my name is Mat Hanson and I'm the Sales Director at Holders Technology. I'd like to first of all just start by thanking Casambi for inviting myself and Holders to come and present today, and also for the attention of all the attendees as well. It's great to see so many people engaged with this Casambi event. So today I want to talk to you about data from Casambi Networks and how this can be used to deliver additional value to clients. And actually, it's been really great to see that there's been questions about data already in the event chat. Obviously, Miko just now talking about data, and Manuel at Tridonic as well touching on the topic. And it seems to be a really hot topic right now for ourselves. So I want to start by talking a little bit about change. And I know it's quite a topic at the moment to think back about how COVID has changed our lives, but maybe to think back, how has our use of space changed over the last 10 to 15 years? And obviously the last 12 months with COVID has really accelerated changes that I think were probably taking place anyway. First of all, there's lots of drivers for these changes, and these are things like technology. So where we're thinking about people moving towards working from home, we've got more and more online meetings, shopping on the web, virtual tours, people doing their online research before they make buying decisions. Environmental factors, people want to travel less, they want to reduce their carbon footprint, less cars, more bikes, all these sorts of changes. And of course, we've become much more conscious about well-being as well. So space, light, clean air, positive spaces, biophilic spaces as well. And obviously that's leading to some pretty major changes in the way that we're all using our buildings and we're using our spaces. As an example, 15 years ago, I was working on a sales floor, lots of people crammed into a very busy office, 6 people to a desk, desktop PCs and landlines, very little natural light, limited facilities, and it was all about maximizing the sales revenue from the space on that floor. What does that type of office look like today? Interestingly enough, the same building today is actually student accommodation, and the question is, what will it be in another 5 years? And I think it's a well-used fact that 80% of the buildings that we'll be using in 2050, that's 30 years away, they're already built. And so if we think about the changes that have happened in those 15 years since I was a sort of wet behind the ears graduate, then what's going to happen over the next 30 years? What's going to happen? What are the demands going to be on those buildings that are already built? And in the shorter term, we design spaces and the lighting within them for our imagined use of that space today. So how many of those projects have we delivered? And then once human beings move into the space, things change very quickly. Humans aren't going to work in a perfect way. What was a meeting room maybe becomes an office, or what was a showroom becomes a design office, or whatever it might be. So nothing really stands still. And we have to look at how these projects are going to work, how they're going to react to the changes that they're going to undergo either next year, the next 3 years, the next 10 years, and so on. So obviously, Casambi, bear with me. So obviously, Casambi is why we're all here today, and it's got a huge legacy estate already, 1.7 million nodes, countless projects, very rapid growth. How many more nodes are going to be sold this year? How many in the next 5 years? So we need to start to think actually now about retrofitting. We need to start thinking about future-proofing. We're designing things, we're building things. How are they going to operate in the future? I think most of us agree that Casambi is a fantastic tool, one of the most robust, reliable solutions for lighting. And as Carrie mentioned in his opening address, one of Casambi's biggest strengths is really in its flexibility. But the question is, how do we use that flexibility? How can we use it now? And how can we future-proof projects to use that flexibility when we need it in the future? And I think the key is really to have quantitative empirical knowledge about the changes in the use of the space so we can understand how to wield that tool and make the right relevant changes. And that shift is in making informed decisions about our lighting and the buildings. And that signifies a change from lighting control into lighting management and then finally building management. So the question then is, how do we do that? What tools do we have at our disposal? And I think the most important tool, obviously, is data. This actually informs us about how sites are actually operating, rather than how we perceive them to be operating. And the question is, when it comes to Casambi, what sort of data is there that's available? And obviously, we know there's a huge ecosystem of products. And actually, when we look into a Casambi system, we can understand there's lots of data sitting there being created that we can start to use. Drivers, especially DALI platforms, are creating energy data, fault data, operating data. switches and sensors. They're creating trigger information, when, where. Lots of tools that are designed specifically for creating data, like power meters, air quality meters, and then other devices. Emergency, we've heard about today from Manuel. And of course, obviously, Casambi itself has a whole set of data, as Miko has just suggested, things like images and so on. So we have all of this data. We've got this huge amount of data waiting to be used for something. And we need to understand how we're going to unlock that data, how we're going to realize the benefits of that data. And the first hurdle is how to get that data out. So it's currently stuck in the Casambi system, either in the BLE mesh, or it's, if we're lucky enough to have a gateway, it might be in Casambi's cloud. So we need to consider how we get that data out. So do we have a local gateway? Do we have something that's cloud connected? And then what do we do downstream? So we need some sort of API connectivity. Who manages that? Who translates that data? And who turns it into something that's intelligible and useful? Once we have the data, we need to then think about what we can do with it and who's going to benefit from that information. So we think about the projects that we work on, whether they're in the commercial sector, industrial, retail, education, healthcare, and we can think about the types of benefits that data can be translated into. So energy reporting, for example, I mean, we could do things as simple as just reading an energy report and billing somebody correctly, or providing comparison to billing. And we can keep our OEM suppliers and our energy consultants honest by making sure that their claims of energy reduction are going to check out. But we can also start to do things like assessing the cost of our lighting against the use of the space. So how does the energy consumption measure up against the occupancy? How does it measure up against the way that we do our merchandising in retail? Occupancy and heat maps. Obviously, with the trigger information, we can create space utilization information. Do we have redundant spaces? Can retailers leverage hotspots in the stores? Does the actual usage match the room or the court bookings that you might have for a space? Obviously, the DALI data itself, we're well versed in using DALI information coming through DALI wired systems. But obviously, when we start to look at things like information for manufacturers keeping warranty, lifetime information, burning information, burning's working in a way that we expect. We then have the controls network communication information and the DALI lighting information, the faults that might be in there. So post-commissioning, we've made changes to the building. Is the BLE mesh still robust? We need to make changes. And the DALI lighting faults, are we able to change our maintenance approach to a more economical, proactive approach and get rid of those inefficient planned and reactive maintenance programs that we probably lean on a bit too much at the moment? And then further data, things like the emergency lighting connectivity. So this is now about compliance. This is now about actually living up to what we need to be delivering to the people that are in the space, having a duty of care to employees, members of the public, emergency services, or anybody else. And then air quality data, are there commercial applications? Can we show that our buildings are going to match up to the WELL standard? And does the story of data stop there, really? We need to then look at how we can have more integrated buildings, how we can get smart buildings. So integration from a lighting management system into a building management system, for example, to allow for wider decisions to be made about the use of the estate. And what about smaller sites with no BMS? Are there other smart systems which we can integrate to deliver more data? A school might not have a BMS, but it might have Casambi lighting, and it might have a cloud-connected heating or ventilation system. So is occupancy data from the lighting system going to be helpful to other systems like your ventilation or your heating? And also we need to think about the fact that we might not want to extract the data on day one, but the client might want to in the future. And none of this is possible without the data being created in the first place. So we should be really mindful of the hardware that we're specifying today to make sure that we deliver the value which we need tomorrow. Do we just want to install the cassette deck from the earlier slide, or do we want to future-proof our projects for the needs of tomorrow? And then there's obviously a whole world of considerations that we have to make when it comes to data. And there were questions earlier today about GDPR, data consent, data security, who stores the data, where is it stored, who manages it, who has access to it, who owns it. When we utilize the data, how do we decide who has access and what they should be able to do with it? Do we have one system for an estate owner and another system for a maintenance subcontractor? Do we give everybody access to the same information? And also, when they have access to that data, should those same people be able to change the lighting configuration? Even, in the top echelons of an estate team, do we want to give access to change lighting levels to someone who doesn't understand lighting? We've done all our work to design the estate to meet the standards, to deliver for the people who are in there. And then do we really want somebody who might be responsible for the energy bill saying, well, I can save 5% of my energy if I just dim all the lights down? So do we want a separation of data and control? So this brings me on to what holders have done. And we've developed holders analytics in response to maybe some of the themes and questions that we've raised today, both in my slides and in the questions that other people have asked. And we've already delivered a large number of Casambi projects, but by using data, it now allows us to take wireless lighting control from Casambi and turn that into smart lighting, and ultimately through integration with other systems into a world of smart buildings. Holders Analytics is an app-based platform which users can use on a desktop PC, on a laptop, on a tablet, on a smartphone, and it draws down the data from the lighting network via the Casambi cloud. And the Holders Analytics app, and this again answers one of the questions that Miko was being asked, will store that data for you for as long as you have the system in place. Because when we want to do real analytics and we want to make comparisons with the way the building's operating today versus 6 months ago, well, we need that information from 6 months ago. 60 days is not going to work for us. So what can it do? What can the system do? So we talked about energy, and as I say, it'd be very easy just to take the API connection and report the data points, and here's your energy. But actually, what we're doing is delivering real value, real analytics to the customer, rather than just the raw data. The user interface, for example, with energy, allows the owner to create profiles, energy profiles, lighting profiles, occupancy profiles, based on the data, giving a representative view of how the estate is functioning on an average day. And the client can then overlay specific data sets to make direct comparisons. And in the example we're showing here, we're looking at the energy data taken over a 3-month window, and it's been used to create an energy profile representing an average day. And this irons out all those peaks and troughs that are created on any one day, and then allows us to compare an individual day to that profile. And in this instance, I think you can see there's been a change in the way the building was used on that day, and it's resulted in a marked energy consumption across the whole site. So let's say it's about 15%. And these reports are then exportable, and they can be used by the client, maybe to model the impact of different staff routines or the way they want to use the building going forward. And ultimately, the lighting energy consumption is being affected by the people using the space differently, rather than a decision to dim the lights. So this is really allowing the business to reduce its carbon footprint without reducing its lighting levels. The business is able to get value which is beyond lighting from the data. And if we start to look at things like occupancy, we can look at collective data over time, and we can understand the general use of the building. So again, we can get average occupancy rates, and we can use conventional Casambi sensors here. So we're not using any Bluetooth beaconing, we're not using any anything that might identify a person. This is just using some basic occupancy data. And this is able to give us information about how the space is being used. Whether the sensors are actually working or not doesn't matter. So the sensors might be in an office where they're used for absence control, contributing to the energy efficiency, switching the lights off. Or, for example, they could be in the estate for the purposes of being used during stocking hours, for example, or cleaning hours. And in normal shopping hours, they're not being used at all. However, they're still triggering, they're still picking up. And we can use that data then to build up hotspots, to build up occupancy plans of buildings. And this obviously allows estate owners to make more informed decisions about their buildings and about whether they need to increase the floor plan as they grow, or if they can better use the estate that they already occupy. And as I say, obviously for commercial projects, this is obvious, but actually let's think about retail projects. Can we use the information about where the busy parts of the store are and the busy times in the store to, can we leverage that data with maybe our suppliers, to negotiate over where we're going to put goods in the store, how we're going to advertise products in the store. So again, completely beyond lighting, but using the data that's being created by the lighting network. Oops. So as we said, Casambi is the standout wireless lighting control solution on the market. But even Casambi can't do everything. And actually, I've been usurped here by the Tridonic presentation earlier. Now, obviously, Casambi have focused really on presenting the best lighting control solution possible. But actually, what we can then start to do is take data from other intelligent devices. And in the example you can see here, we have the analytics platform in the middle, and it's taking data from Casambi, and then it's taking emergency data, which could be from, for example, Tridonic's new wireless emergency hardware. And that hardware is actually then, because it's sitting in the Casambi mesh, it's augmenting the strength of the Casambi mesh, as well as leaning on it and using that to route its own messages. And then reporting the data out into Tridonic's own system. And we can obviously bring that data in through an API, remarry it with the lighting data, and deliver that back to the customer in a single pane of glass. Likewise, data from other connected solutions. So Macwell's Enlight system, again, can be connected via an API, and it can give that seamless view of the lighting estate to the client. And then finally, when we really start to look at smart buildings, we want lighting to be one of a number of intelligent systems in an estate, working in concert to deliver data where it's needed, control on demand, and a building that reacts to its occupants. And Holders Analytics can deliver that data either through its own portal, own web-based portal or app-based portal, or present it in a single bundle of data to a larger BMS or AMS system for wider use. And in time, it will be able to channel commands both ways, so that the lighting can control devices in the BMS network, but also maybe BMS-connected devices could initiate changes within the lighting network. And ultimately, Holders' aim is to deliver a comprehensive, tiered solution, which can deliver not just wireless lighting control, but smart lighting, and then ultimately smart building solutions too.